our project is entitled Improving Waterline Safety at UCLA Children's Dental Center. Our committee is Adriana, Ryan, myself, and Danielle, who's not here right now.
Okay, so we decided to look into a big problem, especially, thankfully not in our clinics, but in other clinics outside of UCLA. We all know about the cases in Anaheim that were unfortunate cases of Mycobacterium abscessum infections. So the problem we were trying to see is if UCLA is prepared or if we have a protocol to prevent a contamination of such magnitude. Okay. So what we decided to do is to collect data for a week. And so here you see the cubicle numbers, and this indicates the percentage of water present. Okay.
I forgot my hearing.
Wow. Okay. So this is we have a chart here of 2 of the dates we monitored the water content in the operatory water. This is the cubicle number, and this is the percentage of water in the bottle. So what we found, based on the protocol, and I'll go over the protocol in a few slides, we found that the protocol of waterline safety is not being followed properly and consistently. Residents, faculty, and staff are not familiar with the proper protocol, and therefore not following the proper protocol can put us at risk of a potential contamination event. So our goal was to ensure that all of us know the UCLA protocol for waterline safety and that we follow it consistently and correctly. So in order to do that, we had an in-service with in one of our huddles, and we reviewed the protocol, which is...
And that was done on the 10th, which is in between the first collection data set and the second.
Okay. So the protocol in the UCLA Infection Control Manual indicates that at the beginning of the day, before attaching any handpieces, air water syringes, ultrasonic units, water lines need to be flushed for 2 minutes. In between patients, water lines need to be flushed for 30 seconds, and at the end of the day, water lines need to be flushed for another 2 minutes, and they need to be purged with air, and all evacuation systems need to be flushed with hot water. At the end of the day, the empty water bottle needs to be outside of the unit to allow for adequate drying. So that's the current protocol in the UCLA Infection Control Handbook. So Ryan will talk about our FEMA diagram.
So because we're looking at a process that hasn't had a failure yet, we did a little different mapping. This is called a failure mode and effects analysis. So over on the left is the actual process step. And I'll show you a process map in a subsequent slide. Sorry. But the main steps are the refilling in the morning, the purging of the lines before we see patients, purging the lines between patients, and then cleaning out the lines at the end. And so we looked at the process potential step failure mode. So it's talking about like in what ways can the step go wrong. So of those 4 steps, we looked at what are all the different failure potentials for that step. The next thing we looked at was what causes the step to go wrong. So is it, do we not have the right training? Do we not have the right personnel? Is somebody not doing their job? So that's where you question, is there negligence involved, or is there just an unknown in the training steps? And then the last thing that we looked at for each of the steps is what are the existing controls that either prevent the failure mode from occurring or detect if it should occur. And so these are things like, is training actually being done? Is there a manual in the clinic that has the step-by-step protocols? Are there any sort of checks and balances? So like throughout the day, can any one of us go into a specific cubicle and say, has this been done yet? Either yes it has or no it hasn't. Or are we relying on somebody to self-report that if we can find that? And one of the things that we found was that the clinic was kind of split up between our 4 assistants. Each assistant had like one of the operating cubicles and then 2 of the recall cubicles. But as you may know, one of our assistants has been out. And so that was something that we kind of found that if we have specific people designated to specific cubicles, what happens if somebody's out? Are these duties being reallocated properly, or is it something that's just being forgotten? Go ahead to the next slide. So this is our overall driver diagram. So on the left is what our goal is. So that's the protocols followed 100%. So some of the primary drivers, at the top, it's the awareness of the protocol for the staff, faculty, and us, the residents. The secondary driver to that is the water safety protocol as part of our clinical orientation. So that's kind of the top priority because it's easiest to accomplish. When we all get here as residents, it's easy for somebody to take us aside and go over the protocol and show us exactly what needs to be done. Some of the other drivers to this, to the success of this, is a clear delineation of responsibility. So knowing this resident's doing this or this assistant's doing that, or is Dr. Silva coming in and doing them all in between. So we know exactly who is doing what job.
Yes.
And so that was important to go ahead and look at. So the next slide is our actual process map. So really we figured out there were two parties involved in this, so the assistants and us, the residents, or the provider, okay? We weren't going to rely on faculty or anybody else that was coming in through the clinic or the students because they're also there. So we kind of took them out of that. Now they can jump in and be a part of this process if needed, like when the students are here taking care of patients, but ultimately it falls on these two parties to take care of. So in the morning, starting from the left, this is a timeline from the morning to the afternoon, so the provider would verify that the bottle is empty from the night before, which means that the duties from the night before have been completed. So the assistant or the provider can fill the workstation. Simple enough. When we have water in the clinic, over in the sterilization area, that's refilled periodically as well. Once it's filled, we flush the lines for 2 minutes, 120 seconds. Patient comes in, we do the appointment. Patient leaves, we just dismiss the patient, and either the assistant that's cleaning up or the provider that's cleaning up is responsible for flushing those lines. That process or that cycle continues throughout the day in between every patient. So the final patient is seen, and then we empty the workstation at the end of the working day.
Okay, so the effects of failure, pretty much this system is set up so that way we have 100% control and know exactly that our water is clean. If any point in this system becomes not 100%, then we can't guarantee our outcomes and we can't guarantee our quality. So that's why we have specific points, for example, at the beginning of the day, in between patients, and at the end. So the potential risk associated with treatment outcomes affected by less than ideally clean water systems in the cubicles will increase. And again, we don't know how much. It just takes every part in order to ensure 100%. So barriers to success, we talked about this last week, that after we did our intervention and started observing what was happening, we found a couple unexpected barriers that we decided to go back and address. So one of them was the possibility of using up all of the water in the water bottles from flushing so often throughout the day. And we noticed this when we would fill up the water bottle, and when we would attach it to the unit and tighten it fairly tight, it would create a very closed system with a lot of pressure. So when you would dispense the water out of the air water syringe, it would come out really fast. So after the 2 minutes of flushing, the water bottle would actually be empty. So in order to combat that, we recommended not tightening them fully, so that way you're still getting water running through the lines. It's just not like a power washer coming out. So you still, don't have to go get more water. It kind of goes hand in hand with our views on trying to not waste water. Obviously, California is in a drought, despite obviously we had a lot of rain. So we are exploring the idea of kind of recycling the water by possibly having a plant. And this is a way where we can show that we're environmentally conscious. This is a really small plant, but it's just an idea. And we would of course have to understand that there might be barriers to that, given like plant life in a clinic. I don't really know, but just trying to explore how we can just not be wasting completely the water that we're using to flush, because although it might not be good for dentistry, it might be able to be used in another fashion. So we broke up our whole process into the Plan, Do, Study, Act. So looking at the top right, you'll see plan. So our plan was the UCLA protocol for waterline safety was reviewed using the UCLA Infection Control Handbook. So it's all there. It's already set up. We didn't have to create a protocol. It must be reviewed with staff and residents because once everyone is made aware, our anticipation was this was something that could be controlled 100% and that we could get 100% compliance. In the do section, we had the intervention, which was our huddle, which includes all staff and residents at the CDC. We reviewed the protocol and then observed our changes. In the study section, we monitored if this was being followed by all, and for the period of 2 weeks to find that the protocol was not being followed per the handbook in the beginning. But then we found that some people were just not. We found that some, but not all, of folks involved at UCLA are following the protocol, and that's why we did the whole intervention and then went back and retook measures. And our question was, okay, so why didn't people know? Was it something that it was a miscommunication during the teaching? Was it that we had so much information when we first got here during orientation that we couldn't remember? Was it something that was just unknown? So possible future plans is to have a laminated card, kind of like the green tooth, red tooth, just to show, hey, this unit's been cleaned. And then we can also have a log of when the lines are flushed. So if at the end of the day you just check off, like, yes, I flushed the lines. But of course, going back, like we want to keep doing this PDSA cycle in order to understand if our intervention and our future plans, if these cards would be practical, again, if the tree would be practical. So you kind of have to keep this process going, and it's the monitoring and evaluation portion of the study. So that's our study.
What questions does anybody have?
So what did you learn about the process of the FMEA, and what kind of key pieces do you think it will take for other projects or other things that might arise in your own life?
Yeah, so I mean, it really kind of comes back to not just what we've done in our FMEA, but also in the discussions we had around QI with other projects that were presented to us. That the simplest answer is may not always be the underlying problem. It may go deeper than that. And so we have to be able to figure out what that underlying cause is to be able to change the overall outcome. So like I think for instance, because we were just in Washington D.C., they were looking at one of the monuments there about why they were spending more money cleaning a specific the Jefferson monument.
The Jefferson, yeah.
And it turned out there was a specific spider there. They thought it was something else.
They thought it was the birds.
They thought it was
with
the
birds,
poops. But it turned out that there was actually spiders, a specific spider that was on that monument that the birds were eating, that then they were needing to clean it more often. So if you get rid of the spiders and you get rid of the birds, you get rid of all the problems. So it's a quick example of showing that it's not always the simplest answer. So for us, it's not just training people. It's not just doing the first step. It's also going to be in the process of retraining people and continuing to have these conversations about why we do what we do and who needs to be doing it.
And the failure modes are really good because it makes you think like what could go wrong. So like for example, if people really feel strongly about wasting water or something, then they might not want to do these protocols. So you kind of have to be able to accommodate and make different ways to get to the same end goal. To like that way you're not forcing people to do something that they don't understand or they don't want to do or they don't find valuable. So.
Excellent. Very good.
So we have the